Now we're going to see the derivation of body force matrix for one-dimensional bar element. Let us see if this is a model point 1 and model point 2. So this is a simple example of one-dimensional bar element. I know that one at model number 1 it has a Q1 and at model number 2 it has a Q2. Okay, so we have seen in the last session that is equal, we have expressed that the q is equal to the displacement function can be specified that n1 q1 plus n2 q2. So the q or let us say it is equal to the small u. So both are called as displacement function. So here the displacement function can be written as u or q. So therefore the small u can be written as it is equal to in terms of the matrix form. I know that only q1 q2 would be the column matrix as well as n1 n2 would be the row matrix. So this can be defined as it is a shape function matrix n into the nodal displacement matrix q. So where shape function matrix n can be defined as it is equal to the row matrix n1, n2, and where q can be defined as it is equal to the q1, q2. So using this notation, today we're going to see that what would be the body force vector for a simple bar element. So to define that one from the potential energy equation, let us recalling the what is the body force term. Okay, so the body force term can be defined as it is equal to the body force term from the potential energy equation from the potential energy equation. So from the potential energy equation, the body force can be defined as it is the integral of u transpose into F into dV. So this would be the body force term for the one line for the from the potential energy. Now the dV can be written as it is equal to the, so here the dV can be written as it is equal to the area into dx. So therefore the potential the body force terms can be rewritten as it is equal to the integral of u transpose into F into area into dx. So we know that one the relationship between the d zeta by dx. So that would be equal to the, it is defined as it is equal to the 2 by x2 minus x1. So from this one it is possible to define as dx is equal to the, where x2 minus x1 would be the length. So dx can be written as it is equal to the L by 2 times of d zeta. So if you substitute here, it can be written as u transpose into F into area into it is equal n by 2 times of d zeta. So here the small f we call as it is equal to the body force in a given one dimension number, or sometimes it is a f suffix b, both are called as a body force. So now let us try to define now what is a body force matrix for an element having a nodal number 1 comma 2. Okay, 1 comma 2. Okay, here u transpose can be right as it is equal to, I know that one u would be, this is equal to the n into q. So if you write down that one integral of n q as a matrix and to the power of transpose, this is called the u transpose into F into area into L by 2 times of d zeta. Okay, so here the F is constant, take outside, and the area is constant, the length is constant, and divided by 2 is also constant. And you're going to see that there is a q to the power of transpose, that is also, let us think that as outside, it is called q transpose, only integral of n transpose matrix into d zeta. So here n is called shape function, and we know that the shape function n matrix would be the n1 comma n2. So where n1 we know that it is equal to 1 minus zeta by 2, and n2 would be equal to the 1 plus zeta by 2. Substitute into the above equation. Okay, so let us rewrite that equation in the next slide. So if you write down that one, I can able to write down that is equal to the f into, this is called f into area into L by 2 into Q transpose integral of n transpose into the d zeta, and limits are -1 to +1 only. So the n matrix would be is equal to the matrix n will be the n1 comma n2. It is a row matrix, so therefore n transpose will become that, it would become that column matrix n1 n2. So integration of these two. So we will going to write down that again. I can rewrite this Q transpose of f into a into L by 2 integral of n1 n2 matrix into d zeta. The limits are -1 to +1. So means that I can able to rewrite this on Q transpose F into A into L by 2. So N1 can be write as it is equal to 1 minus zeta by 2 into d zeta. We have to write down integral -1 to +1. And again that the next element would be the -1 to +1. It is called N2, that is for 1 plus zeta by 2 by 2 into d zeta. So this would be the body force term for a given one dimension member. So if you do the integration, therefore you're going to get that it is equal to the 1 minus zeta by 2 into d zeta can be integrated as it is equal to the zeta can be integrated as it is equal to the zeta square by 2. So zeta square by 2, and we're going to write down. So if you do the integration, therefore, you are going to get that 1 minus zeta by 2 with respect to the d zeta, and put down that -1 to +1. You are going to get that this is equal to 1 value, and bottom also you are going to get the value equal to 1 value. So therefore, it is possible to define that it is equal to the Q transpose of is equal to the rho into f into a L by 2 1 comma 1. So this would be the body force term for a given one dimensional member. So here this is called as an entire body force term, but for a one dimensional member having a body force F, that is in the Newton per meter cube. So therefore the body force matrix can be written as it is equal to the body force matrix, and this matrix can be written as Q transpose into the body force for a element. So here the Fe body force for a element can be defined as it is equal to the small f or small f suffix b into area into L by 2 into 1 comma 1. So this is a formula for the body force. If the element subjected with the body force F, then you need to be find out that the for a particular element the body force matrix. Thank you.